Before we start solving questions, we have to understand the FBD's free body diagram. So let it be a box or a book or anything else lying on the table. It will exert a force that is due to its weight. That's the gravitational force that will point downwards. That is mg. Its mass multiplied by the acceleration of the earth, as it is on the earth's surface. So we will be taking the acceleration as g. So the book on the book, the table will apply a force. It's normal, that is that will pass through the center of mass. So I am drawing it here to make it visible. It will cancel out the mg force, mg equal to normal. Similarly, if let's suppose we are just holding this book against the wall, we are applying a force F. Here it is mg, here it's normal, and here for keeping it, for prevent it from sliding, we will add some friction, means the floor will add friction to prevent the sliding of the box. So basically I am drawing it for the questions which we will solve later on in this video. I will solve a question. It's here. Actually, these are the questions of class 11th and 12th concepts, but I will be discussing here because of the FBD. If you understand the FBD, the purpose of FBD, then you will be easily able to solve other questions also. So basically here, if you see, the both forces are cancelling out each other. If its friction is the friction is not required here, because here both mg, there is no acceleration, so there will be no sliding of either weights. The total part is in equilibrium. So I am drawing the FBDs. Here tension is cancelling out tension, here tension is cancelling out mg, here tension is cancelling out mg. Similarly, there are many cases. So let's solve the question. When a body is placed on a tabletop, it exerts a force equal to its weight downwards on the table, but it still does not move or fall. See, name the force exerted by the table on the top. Normal force exerted by the table. What is the direction of the force? Upwards, as I drawn it here. On what factor does the position of the center of mass, gravity of a body depends? I have mentioned it in the previous videos. The theory part I have already taught. I have already gave the video. Check in the playlist. SI unit of force is also done. Factors of affecting the turning effect, I have also done it. Define equilibrium, it's also done. The beam balance is balanced on in a horizontal position, it's in equilibrium. The beam balance is balanced in a horizontal position, is it in equilibrium? It's a little bit controversial, because it's had not mentioned whether it is balanced in the center or on the sideways. See, balanced, acha, is in static equilibrium. Yeah, it's right. If it is balanced in the center, then it is static equilibrium. Explain the motion of planet around the sun in a circular path. It's due to the centripetal force. See, centripetal force. You have to just describe the thing. The metal ball is hanging by the string from a fixed. You have to draw the FBD. I have drawn it before, I think. No, let's see. I'm doing it here. It is a ball of mass m or a block, some whatever it is. The tension mg, it's balanced. Mg means the weight. The force is applied on a non-rigid body and a rigid body. How does affect the force differ in above two cases? When the force is applied on a non-rigid body, first it changes its shape of the body, then changes the state of rest or state of uniform motion of the body. It totally depends upon many factors. This question I think will not come, but then also I am telling that a rubber ball when or elastic ball when falls on a ground, it rebounds, it doesn't rebound with the same speed. Okay, this type of questions come in 11th collision chapter. This ball falls with a velocity v. When it gets up in up direction, it will not reach the same height at it was before. It will go with some velocity v, ev velocity. E is coefficient, is a coefficient. It depends. E is less than 1 and greater than 0. So leave it. I am just telling it to for this purpose. I am. And when let's go move on to the rigid body. When a force is applied on a rigid body, it directly changes the state of rest or state of uniform motion of the body without any change of shape. That's okay. That's done here. What is the weight of body placed at the center of Earth? It will be 0. Yes, it's 0. Oh, at the center of Earth, see, at the center of it's saying that it's a sphere. At the sphere, the center of mass, it's present at the center of mass, then it will obviously be 0, because the force, what I said is the torque is F cross R, means F cross R means F R sine theta. If R is 0, then obviously the force, the weight or the force applied by the earth, that's gravity, is obviously 0. The torque 0 means it's 0. The force is directly passing from the center pivot or the axis. So it's the reason I am explaining it in depth, because I will do more 5 to 10 questions more for conceptual clarity. Then I will move on to the next topic, means the questions, and I will not focus on the theory based questions more. Possible, is it possible to have an accelerated motion with a constant speed? Yeah, it's possible. See, let's suppose it's a moving body. A force F is applied to it. Okay, and there is a friction force. That's friction is applied with the force, like you are rubbing your finger against the copy, then the copy is providing a friction force. That's I am moving my finger to in that position, it will oppose the force, means my motion, so it will apply a force in the opposite direction. So basically, a friction is a force. If force is applied here and if here, the force F net, we know the formula of force, F equal to mass into acceleration. Then F net will be mass net. Here mass is constant, so acceleration net. So the acceleration net will be F minus F. Let's suppose the body is moving in this direction, then F minus F divided by mass. If F becomes equal to friction, means this force becomes equal to friction, then it will move in this direction with a constant velocity. So basically here it is said that if it is possible to have an acceleration motion with a constant speed. Yes, constant velocity, constant speed. This here the body is moving in the same path, and the speed is constant, and the velocity direction is not changing. That means velocity and speed is same in this case. Yeah, see, yeah, I don't know which question's answer is this. Let's move on to this question. One end of spring is kept fixed while the other end is stretched by a force as shown in the diagram. Okay, copy the diagram and mark the end's direction and restoring force. So before we solve this question, let me tell you about the restoring force. Restoring force is nothing but the force applied by an object or the spring. Here we will take the example of spring, so understand by it. The restoring force is the force applied by the spring to achieve its natural length as it was previously. Like you have seen the spring. See this type of spring. When you stretch spring like structure, when you stretch the spring, it will uh, try to come to its exact actual state it was before. That's the restoring force. You apply force in this direction, it will apply restoring force in opposite direction. So here it is said that direction of restoring force, see, direction of restoring force is opposite to the force applied. Name one instrument which works on this above principle. I will say spring. There are many a lot things, springs used in machines, then jumping jacks that spring balance is also correct. Two effects of forces on non-rigid body: it can change the shape and size of the body, it can also change the state of motion. Center of gravity of a uniform ring at the center. Position of the unchanged when the body is deformed. Position of the center of gravity of a body remains unchanged even if the body no, it's see the false, because if the shape changes then it will obviously change. Which reference to direction of action? How does a centripetal force difference? I have already done it. The difference I have given: 1 kgf is 9.8 newton, approximately 10 newton. What are non-contact force? Non-contact force are those force that are applied by a body without being having physical contact with other body or other object, like gravitational force, electrostatic force, nuclear forces, etc. There are many. See, how does the distance separation between body affect the magnitude of I think this question is not needed. It's the question of gravitation. But I will just take an example. It is inversely proportional to r. As the r increases, it decreases. What do you mean? What is meant by the moment of force? Torque. The definition I have already given. Assigned in the negative sign to the tendency. This is also done. Which of the following remains constant in uniform circular motion? Uniform circular motion, the speed remains constant, the velocity changes. I have explained it. Name the force required for uniform circular motion. Name the force required for the uniform circular motion. Centripetal force is also correct. Tangential force or centripetal force? No. Yes, only centripetal force. 1 Newton is defined. Yes, you can add this also. 1 Newton, definition of 1 Newton. Okay. Name a design. Spring balance. Physical balance or beam balance is used for measuring mass. Spring balance is used for measuring weight. Body weights 360 degree is 360 Newton on Earth. See, 360 Newton means it's 36 kgs the mass, because g, if we take g as 10, so 36 will get multiplied with the acceleration on the moon. That's 1/6 of, I think 1/6 of g. So our answer will be 36 g into 6 means 6g. 6g means 60. Simple. We know F equal to m into a. The gravitation is a is changing. Similarly, F means weight. Weight means m into g. The we will find out the weight means the mass. Then we will put the mass here. 36. Actually, it's 36. Then see, weight on, its weight on Earth. Mass we will find, the mass we will find as 360 by g. Weight on moon equal to g 1/6 of g, and 360 by g. Cut it, 60. Simple calculation. What to define the term momentum? So here I will define the momentum. Momentum is m into v. Before, okay, let's define. See, we can also write force as change in momentum by change in time. It's minus sign, but avoid the minus sign. We will deal with the magnitude only. Delta p, delta t. I will derive this. See how. Force equal to mass into acceleration. Acceleration is dv by dt. You have read this in class 9. Mass is constant, so we can take it inside. I know it's a little bit confusing, but just see and follow what I am doing. dp, see, momentum by time equal to force. This will be used later on. See, so the condition when the change of momentum depends on the change in velocity. See, from this they have derived it. You can also do this, but I prefer this. Change in momentum, in mass, velocity. Do this. This is homework for you. Just copy the questions. I am showing it once. Oh, this is an interesting question. Draw the graph showing relation between acceleration, mass for a constant force. Okay, acceleration versus mass means here I will take acceleration, here I will take mass. Acceleration and mass. Okay, I will relate it with force, mass into acceleration. If force is constant, F by m, means acceleration is inversely proportional to m. That means the graph will come like this. See, let's see the graph. So that's all the same thing, same stuff. See, is a unit of momentum, you know, where momentum is mass into velocity. Mass is kg, velocity is meter per second. So the these things. A body of mass, let's solve this question. A body of mass 1 kg is thrown vertically up with an initial speed 5 meter per second. What is the magnitude and direction of force due to gravity? Magnitude and direction of force due to gravity on the body when it is at the highest point. Okay, let's see, it's the question of kinematics class 11 concept, but it will help you. H max. So we don't have to learn any formulas. There you will see formula, but I will not, sorry, this, avoid this. It will go straight up to a H max height. It's launched with a velocity v. See, you have just have to learn the three formulas of kinematics. That's very important. V equal to u plus at, s equal to ut plus half at square, and v square equal to u square plus 2as. Here the direction, they all are vector quantities, but we will take the direction upwards. So see, we have to find magnitude and direction of force. So I will take this equation at the its velocity final. V is velocity final, u is velocity initial. So v velocity final, here I will throw it up, it will reach some height and then it will stop. So velocity final or v is 0. So we don't have the time given, so then we will use this equation. I first thought t was there, but there is no t given, time. So velocity initial is u, so the u square equal to, here the acceleration is g, but we will take negative g because we have taken the direction upwards, but the gravity is being applied downwards, so the direction is g and negative. So u will h, we have to find the h max. H max is coming out to be u square by 2g. So we will put the values here. H max, u square, initial velocity was 5 square, G is, let G to be 10, be 10, 25 by 20, that's 12, 1.25, I think. Yes, 1.25. See, 1.25. Magnitude of force applied. H max. Oh, at what is at its height when its highest point? Oh, we have to find the force when it is at the highest point. So when it is at the highest point, the gravitational force will be, okay. Oh, that the force will be mg only. Oh, mg only. Sorry, my mistake. That will be mg only. So mass, it's 1 kg into g, it's given 9.8, is 9.8 newton. Oh, this, it's not wrong. I mistakenly taught the concepts of class 11th, but you can learn these three. That, let's suppose be it's let it be a ever this question. Leave this is advanced for you for class 10, but it's basic for class 11th and 12. Define the SI unit of force. I've already taught it. See, next question, ICC solved. A nut is opened by a range of length equal to 20 centimeter. We have to convert it in meter. If the least force is, if minimum just to turn the range is 2 newton, moment of force, torque I have sent F into L or R, that's 2 into 20 into 10 to the power minus 2, that's 40 into 10 to the power minus 2, that's 0.4. See, 0.4 Newton meter. Okay. Next question, two forces 5 Newton each act vertically up and down respectively on ends of this is the question. Placed at the midpoint shown determine the magnitude of resultant movement. So here for the movement of about the midpoint, for this we have to add both of this movement. Let torque 1 and torque 2. Torque 1 is, let this be 1 and this 2. Torque 1 is 5 into, that's 50 centimeter, then it will be 50. So it's half because I am converted into meter. 50 into 10 to the minus 2. This is in Newton, this is in meter, because 50 centimeter converting into meter. 250 into 10 to the power minus 2 equal to 2.5. Similarly, this is also 5 into 50 into 10 to the power minus 2, 2.5. So 2.5, 5, because see, both are in same direction. Complete the circle. This moving this in the anti-clockwise direction, it is also in the anti-clockwise direction. So these two will add up. See, total 5 anti-clockwise. Okay. Let's solve this question. A boy of 30 kg is sitting at a distance 2 meters from the middle of the seesaw. Where should a boy of mass 40 kg sit so as to balance the seesaw? See this question. A boy of mass 30 kg is sitting at a distance 2 centimeters from the center of the seesaw. Means this seesaw is also 2 meter long, because it is written it's the middle of the seesaw. So where should a boy be kept to balance it out? A boy of 40 kg. M2, it's M1, sorry. So according to the torque concept, basically according to 10th point of view, sum of anti-clockwise movement equal to clockwise movement. And so anti-clockwise means it's clockwise, it's anti-clockwise. 40 into, let's suppose the distance be x and it's 30 into 2, so x is coming out to be 60 by 40, that's 3 by 2, 1.5 meter. Means it will be, for the 40 kg mass will be kept at 1.5 meter distance for balancing it out. See, 1.5 meter. Let's do the next question. This type of question, the probability of coming is really high. An uniform scale, meter scale, can be balanced at the 70 centimeter mark. Okay, let's see the diagram. It can be balanced at a 70 centimeter mark when a 0.05 kg is hung from the 94 centimeter mark. Means 24 centimeter away from it. Okay, draw the diagram and the arrangement. Yeah, you have to draw this. Yeah, before drawing is, see, it's balanced at a 70 centimeter mark. Mass is balanced 94 centimeter mark. See, there is a weight of the when a mass, there should be a weight of the balance, means the scale. You are balancing on a scale, it's the common sense, the scale also have the weight. So see, what we have learned, the center of mass of the rod, we are taking this as a rod, is at the center, so the weight of the scale should be taken at the center, means 50 centimeter mark. The mass of the scale mg and its mass mg. See, so to balance it out, if there is no further weight added on the sidewise, so balancing it out will be, this distance is 24, so anti-clockwise movement is this gap is 20, so mass of scale into 20 equal to mass, or mass is 0.05 into distance is 24. Here you can also take in meter, but it will ultimately get cancelled out. So mass of the scale is coming out to be 0.05 into 24 by 20. So if I take 5 into 24 by 2 into 10 to the power minus 3, 6 into 10 to the power minus is 0.06 kgs. Okay, you have to write a little bit so that they can give you 4 or 5 numbers, whatever the marking is. This question I am giving it as a homework. Do it, I will not solve. So here we will solve this question. It's speed versus time graph. So the distance covered by the car in 5 seconds will be this area under the curve. Don't write the total area. Okay, it's only the area under this line or curve given in the question. So the area is half into 5 into 20, that's 50 meter. Then acceleration will be change in speed into change in time. It's if it was velocity it would be the same. So changes is 20 minus 0, 5 minus 0, that's 4. See the answer. This is a homework for you. Find it. It's interesting, but that's not really hard. If you give it some time and try to solve it by yourself, you will get a conceptual clarity. So this is homework for you. This is a good question. Just see this type of theory based question. I will not explain it more. Read the things, and because I have already explained a lot of things and everything is not possible for me, just take the screenshot or read the questions, pause the video, watch it again and again. The person falls from the concrete fall from a height, he experiences a large amount of force. On the other hand, the person falls on the mattress or on a sofa. Obviously the change of momentum, you have to relate this type of questions with force equal to change in momentum and time. The concrete hard surface, when person falls on a concrete, it exerts a reaction force, whereas the sofa, when a person falls, causes deformation. It's rigid and it's non-rigid. That are the 2 points. First point is the reaction force applied by the concrete force because it is rigid. The second point here is it's non-rigid and it does not apply the reaction force. But I am not explaining these questions, just see this question. This is the last and the important question. This is the maximum hardness the examiner can give. Force versus acceleration. Force equal to ma, so it's directly proportional. So you have to draw this type of graphs. If it is mentioned that force and momentum versus momentum, it will be straight graph if the time is constant. If force versus time is given, then this graph will be like this, U-shaped, because like this. So you have to do it by yourself only. So let's see this question. It's also in your Conscience Selena physics book. So see, the diagram shows a heavy roller. Leave everything. Here in this question it is written that you have to find the minimum possible force applied for moving the roller. Minimum possible force means you have to produce a maximum torque by applying minimum force. That means the R perpendicular should be max. So you have 3 places where you can apply forces. Here it's not possible, so it is only 2 places, one like this, one like this. You can also apply force here, but it ultimately will result in nothing. See, here the torque is being generated, so the pivot is here, but from here you have to generate maximum torque. So you have to apply a force here for to getting the R perpendicular maximum. That pivot will become this if you apply force here. For this, the R perpendicular or the R is shorter as compared to this, so it in this place will be more suitable. So I will read this for you. To raise the heavy roller pavement CD, a moment of force is required. We know that the moment of force or torque acting on the body is equal to the product of the magnetic force and perpendicular distance of line action of force from the axis of rotation torque. Therefore, the particular amount of turning effect, the magnitude of force will be minimum. Perpendicular distance is maximum. See what I told you. We know that the diameter is the largest chord in a circle. What I said you before. Largest R maximum. So therefore the point P at which the minimum force should be applied must be diametrically opposite to the C. That means P. Diameter means the whole thing. 2 times the radius. So direction of minimum force must be CP. See? Very easy. Last question of this chapter. I am making a question of mine. Let the beam balance be balanced at 20. Let's it be 30. I will hang a weight of 50 kgs at 10 centimeter, and at 0 I will hang 30 kgs. What will be the weight I will hang at 90 kgs to balance it out? Okay, let the mass of scale be 40 kg. So see, here at 50 there will be mass of the scale, that is for this mass. Mass I have to find. This mass is 40 kgs. So the total anti-clock movement is equal to clockwise movement. So first distance is 20, second distance from this pivot, the point, is 30. For this it is 20, for this it's 60. So first 30 kg into g means equal to 10. I am taking it 10. So 300 force, I am writing the weight or force applied by 30 kg. It is at a distance 30. So 30 plus, I am writing the anti-clockwise movement, 50 into 10, 500 into 20 equal to this 40 into 10, 400 into 20 plus the mass into 10 m into 60. I am writing this force into r perpendicular. Okay, so this is 10 into 10 to the power 3, that is 19 into 10 to the power 3. It's 8 into 10 to the power 3 plus 6m into 10 to the power 0.6m into 10 to the power 3. So 19 minus 8 divided by 6 equal to m. M is coming out to be 11 by 6, that is approximately 2. I am not calculating it out. If I calculate, it will be 48 to for 2, it will be 3 1.83, approximately 2. So this type of question will come. This is the maximum difficulty. No one will ask you for more difficult than it's all. So practice more and more. Practice the questions given in the back of the book, of your book, which you are following. The more you practice, the more fluent you become, the more number you get. So it's up to you. I have given my best. So like, share, subscribe, and try to learn the physics by heart. I have explained each and every question in a very detailed way. So it's your duty to revise it. I've also provided the notes, and my Instagram is also mentioned in the description. Text me in the Instagram for the notes and the short notes, or further more, if more questions are needed, I will provide it. Practice. The more you practice, the more you get better. So don't mug up the physics. Physics is not about memorizing all the theories, all the numericals in your back of the book, and go and vomit it out in the examination. Physics is all about understanding. If you don't build conceptual understanding in class 10th, you will literally face difficulty in class 11th and also in 12th, and you will not be able to study and you will get afraid of this physics stuff. So according to me, the way I am teaching, try to learn it, try to understand what I am trying to say. Ask question. Do ask question. You ask your teachers, whether your seniors, anyone, but clear your doubts.